Welcome to the session Blockchain Applications in Business Management. Today's session we are going to deal with Introduction to Blockchain Technology, Characteristics of Blockchain Technology, Components of Blockchain Technology, Types of Blockchains like public, private, consortium, hybrid, consensus mechanisms, blockchain applications in business management, and we are also going to take certain blockchain industry specific use cases like how it is applicable in certain industries. We will also be looking into certain trends in blockchain management like Web3 and decentralized apps, DApps what we call it as. Blockchain has been one of the innovations which has transformed the industry. Blockchain is irreversible record of transactions which can be immutable, which means it cannot be deleted or changed once created. Now, certain applications in the computer field required blockchain. Let us look into the formal definition of blockchain. A blockchain is a revolutionary technology that has the potential to transform various industries. It is decentralized, distributed ledger that records transactions in a secure and transparent manner. Now, there were multiple transactions which were happening in the finance sector which required data transparency as well as data authentication. Now, there were multiple applications available, but blockchain came as a blessing because of its key characteristics. Let us look into some of the features of blockchain technology. The first feature is decentralization. Blockchain is a decentralized network, which means that the decision making power is spread across the network of nodes. The second characteristic is immutability, that is, once recorded, transactions on a blockchain cannot be deleted or modified. Now, this ensured the data once created was time-stamped and hashtagged and stored in a particular ledger. Now, this would also be visible for others, but it could never be destroyed. Now, when we say like the data was visible to others, it was allowing transparency. That is the third key characteristics of blockchain. Transparency, that anyone with an internet connection who belong to the group could view all the transactions on the public blockchain. Enhances security. Since blockchain is using encryption and other security measures, it was easy to protect the data. Blockchain uses something called as smart contracts. So, smart contracts are self-executing protocols that automate transaction verifications. Distributed ledgers, that is a shared database that records all transactions and is accessible to all network participants. It creates transaction hashes. Each transaction is assigned a unique ID called a transaction hash, which can be used to look up the transaction record. Every time the data is created, it timestamps. Time and date stamping all transactions would create a permanent record in the ledger. Having understood the key characteristics, let us try to understand what are the different types of blockchain. There are 4 types of blockchain: public, private, consortium and hybrid. The diagram here clearly tells us what are these 3 different types of blockchains. The public blockchain allows us to write, approve as well as read. A public blockchain is an open network which is accessible to anyone and verified by anyone on the network. Its key features and benefits include transparency, security and decentralization. A private blockchain is designed to be used by the permissioned group of users. Anybody who belong to the network and who were authenticated or permitted only could be able to see the data. A consortium blockchain is a blend of private and public blockchain features. It allows for controlled access and shared governance among a selected group of organizations. This setup ensures that no single entity has complete control, promoting a democratic and secure environment. Now that's what the meaning of the consortium, like group, which means. An hybrid blockchain could be a combination of any of these. Now let us also try to understand the blockchain layers. We have layer 0, which consists of software infrastructure, layer 1, which consists of blockchains or networks, layer 2, which consists of sub-blockchains, and layer 3, which consists of decentralized applications, or what we call it as DApps. Now this layer creation has been greatly beneficial for the financial transactions with the help of blockchain technology. Now let us make an effort to understand the core components of blockchain technology. Nodes are individual computers that participate in the blockchain network, and each node stores a copy of entire blockchain part of it. Now there might be three different types of nodes, like full nodes, partial nodes, and mining nodes. So full nodes maintains a full copy of all the transaction, and it has the capacity to validate, accept and reject the transactions. While partial nodes are called as lightweight nodes because it doesn't maintain the whole copy of the blockchain ledger. It maintains only the hash value of transaction. So the whole transaction is accessed using this hash value only. These nodes have low storage and low computational powers. Now mining nodes are those which validate the transactions and add them to the blockchain. So typically they are the process called as mining. So they are also called as the proof of work systems. Now the blockchain serves as a ledger, basically as a distributed ledger. So a distributed ledger records all transactions in a secure and immutable manner. It is composed of blocks, each containing a set of transactions, timestamp and a reference, what we call it as hash, to the previous block, forming a chronological chain. Now a ledger might consist of public ledger, which is open and transparent to all, a distributed ledger. Now in this ledger all nodes have a local copy of the database. So here a group of nodes collectively execute the job that verify all transactions and add blocks in the blockchain. A decentralized ledger, no one node of group or nodes has a central control. Every node participates in execution of the job. Now the other component of blockchain is transactions. Transactions are fundamental units of data in blockchain representing the transfer of value or information. A transaction is created, verified by node and then recorded on the blockchain. This typically includes the sender's and receiver's address, the amount and the digital signature of authenticity. The fourth component of blockchain technology is consensus mechanism. Now in consensus mechanism, algorithms allow the network to agree the validity of transactions and maintain a consistent state of the ledger. Now we have four mechanisms under this, like proof of work, which requires participants to solve complex mathematical problems to validate transactions. One of the best examples for this is Bitcoin. Proof of stake, where validators are chosen based on the number of coins they hold and are willing to stake as collaterals. So the best example for this is Ethereum. Delegated proof of stakes, which is called as DPoS, where participants vote for a small number of delegates to validate transactions on their behalf. Now apart from this, there are also multiple other supporting components in the blockchain. The other important component is a smart contract. A smart contract is a self-executing contract with terms written directly into the code. Now this also runs the blockchain. Now it consists of automation, where they automate the contract execution without the need for the intermediaries. So this reduces cost and increases efficiency. Certain conditions need to be predefined. A smart contract can execute actions when predetermined conditions are met, such as transferring funds or issuing tokens. Use cases commonly used in various applications including supply chain management, insurance claim, or decentralized finance, or what you call it as DeFi. Another important component is tokens. Tokens are digital assets that are created on blockchain that represent various utilities, rights or assets. There could be utility tokens like Ethereum's Ether, or security tokens which could represent the ownership in real world assets such as stocks or real estates. Stable coins like cryptocurrencies designed to maintain a stable value, often pegged to as a fiat currency. So all the components of a blockchain like a node, a ledger, a consensus mechanism work together to create a secure and transparent transaction within the blockchain. Supporting elements like cryptography and smart contracts further validate the functionality and interoperability. One of the major benefits of using blockchain technology is it enhances security, allows increased transparency. Since there are a lot of preset automated processes, it reduces cost and elimination of intermediaries. Now, there are certain challenges in the blockchain. It includes scalability issues, energy consumption, interoperability between different blockchains, regulatory uncertainties, and the need for user-friendly interfaces. Now let us look at certain examples of blockchain. Blockchain technology is also used in supply chain management for tracking goods and materials across the supply chain, ensuring authenticity and preventing counterfeiting. Blockchain technology could also be used in healthcare for securely storing and sharing patient medical records, which improves data interoperability and patient care. Now also another speculation is blockchain technology could be used for voting process, which enables secure and transparent elections, reducing the risk of fraud and manipulation. Blockchain technology could also be used for providing digital identity, like providing individuals with secure and verifiable digital identities, simplifying online interactions and reducing identity theft. Now, blockchain technology still has a lot of challenges as we discussed earlier. Now, when we look at the recent trends, blockchain technology has been used in Web3 and Metaverse also. Now, when we talk about Web3, since 1990s, the internet evolved. We need to understand the evolution of Web 1, 2 and then 3. Web 1 was initial days of internet where the communication on the internet data or the media would be one way. It used to be a simple HTML page like this. We could see most of these pages were not interactive. Most of the data on the website would be static. Now this simply means like the data would just be there and frequently updating would be difficult in Web3. It were simple combination of HTML frames. www, World Wide Web. Web 1, Web 2, Web 3 are the concepts related to World Wide Web, that is internet. Now the internet websites distributed with the help of www went through 3 stages of evolution. Web 1, which was more static and limited with user accessibility and other moderations, was used until 2000s or 2004. Now, as and when the internet technology developed, Web 2 saw few interactions. Even now, we are in Web 2. So, there is two sides of communication. There are a lot of advantages with two-side interactions or two-way communication. Two-way communication or Web 2 has enabled interaction from both the sender and the receiver side. Now this has given scope for information exchange to buying and selling activities on the internet. Web 3 is something which is going to happen and it is basically designed on the concept of decentralization. Now in Web 2, whatever data we are creating on internet, we are not the owners, which means the people who have designed the website or the body which is handling that particular portal would be the owners of the data. In Web 3, whoever is creating the data is going to be the owner of the data. Now to understand what exactly is Web 3, let us look into this definition. Web 3 refers to the third generation internet which focuses on decentralization, and it is also majorly the concept of blockchain technology. It empowers users to have control on their own data, digital assets and digital identities. It majorly represents a shift from current centralized model of the web to large tech companies where they're controlling platforms, data and flow of information would be shifted to the user side, like the person who owns the data. So he will be called as the user. Now, decentralized finance or DeFi is also part of Web3. DeFi refers to financial services like lending, borrowing and trading which are built on blockchain technology, cutting out the need for traditional banks or financial intermediaries. Web3 is a big enabler of DeFi as users can engage in financial activities through the centralized protocols. So the people who create the data, the ledger, are considered as the owners of that data block. Another major consideration for Web3 is DApps or what we call decentralized apps. DApps are applications that run on a blockchain or decentralized network rather than on centralized servers. They are open source and typically operate without a central authority. Some of the examples include decentralized finance platforms, social networks and gaming applications. With this, we also have NFTs or what we call it as non-fungible tokens. NFTs are unique digital assets that are stored on a blockchain. They can represent ownership of anything from art and collectibles to real estate and music. Web3 provides the infrastructure to create, buy and sell and trade NFTs in a decentralized manner. Now, this is where Web3 was playing a prominent role in creating the data to owning or transferring. So, Web3 focuses on users' sovereignty over their data. Web3 allows the user to maintain his own data without the interference of the third party. Until now, as internet users, we are dependent on our internet service provider. Once Web3 is implemented, those companies should transfer the data to the user. Right now, since companies are owning the user's data, big companies like Amazon, Google, Flipkart are able to absorb the data patterns since they own the customer data. Now let us look into the key benefits of Web3. Web3 allows control and ownership of data, where users can control their own data, identity and digital assets without being dependent on centralized entities. Since Web3 is based on blockchain technology, it is more secure and makes harder for data breachers and hackers to cause threat. Web3 is also more transparent. Since the operations on blockchains are transparent and publicly verifiable, it enables more of open data. Web3 is more beneficial. It aims to create ecosystems where participants are incentivized fairly for their contributions, often via tokens or cryptocurrencies. Now, we might be hearing more about cryptocurrencies and tokens. So, now these are all possible to be verified digitally. Now, Web3 is also still in its nascent stage, which means it is still evolving and hasn't captured the market yet. So, there are many challenges with respect to Web3. Some of the challenges what we can list are scalability, user experience and regulation. Scalability, because many blockchain networks like Ethereum currently face issues with scalability and high transaction fees. This limits the widespread and adoption of technology. User experience, like interacting with Web3 applications, often requires a basic understanding of blockchain technology. This can be daunting to the regular users. The third challenge is regulation. The decentralized nature of Web3 presents challenges for regulation, especially concerning financial activities, privacy and intellectual property. Some of the examples for Web3 technologies are Ethereum, a decentralized platform for building and running smart contracts and decentralized apps; Polkadot, a multi-chain platform that facilitates interoperability between different blockchains; Filecoin, a decentralized storage network where users can store and retrieve files securely; Uniswap, or in simple terms it is also called as DEX, decentralized exchange of trading cryptocurrencies without intermediaries; OpenSea, a marketplace for buying, selling and discovering non-fungible tokens; Web3 integrates cryptocurrencies like Bitcoin, Ethereum, and other cryptocurrencies, allowing the peer-to-peer financial transactions without needing for a centralized bank. Another benefit of Web3 is the smart contracts. The smart contracts are self-executing contracts with the terms of agreement directly written into code. Now, these contracts automatically execute when predefined conditions are met. For example, in Web3, a smart contract might facilitate the transfer of ownership of an asset when a payment is made without needing an intermediary. Let us recap the session highlights for today's discussion. We started discussing the fundamentals of blockchain technology, characteristics of blockchain technology, types of blockchain like public, private, consortium, and hybrid, consensus mechanisms, various blockchain applications in business and management. We took few examples on how it is applied in the industries. Towards the end, we discussed trends and innovations in blockchain management like Web3 and decentralized applications, DApps, integration of blockchain with AI and IoT. Let us now take a look into some of the interesting facts, reference for this section. Thank you.